Hi and thank you for joining me. In this video we're in the wonderful world of algebra and we're looking at a particular skill which some people do find a little tricky. We're going to look at how to solve simultaneous equations. And I think what confuses people is there are four routes that you might have to take in order to solve any given problem. So here we're going to have a look at the four methods and try to identify when each of them is most appropriate. Let's make a start. Let's start by having a look at exactly what we mean by simultaneous equations. You see on the board here we have two equations, and the reason they are simultaneous is because they are both true at the same time for the same values of x and y. So for a given value of x and y, 3x plus 2y equals 7, but also 5x minus 2y equals 1. And we can use the two equations to find the values of x and y. The way we do this is to eliminate one of them in order to find the value of the other. Now, unfortunately, there are several ways to do this, and we need to look at them all because when faced with an individual question, you need to decide which is the best method forward. Let's first of all give each of the equations a number. So the first one can be 1 and the second one can be 2. It is good practice to write down the steps you are taking in a question like this. The first method that you can use is to add 1 and 2 together. So we're actually going to add the two equations. Let's see how this works. Well, we have 3x and 5x, so that gives us 8x. If we add the y's together, we have plus 2y minus 2y. That leaves us with nothing. Therefore, we have eliminated y. We then add the equals. 7 plus 1 is 8. So we now know that 8x equals 8. By slightly moving things around, that means that x equals 8 divided by 8. Therefore, x is equal to 1. And this is the first part of our solution. Now what we need to do is to substitute that value of x into one of the equations. So we're going to substitute x into, let's choose the first one, into equation 1. This simply means that the value of x is 1, so we're going to replace the x with 1. We therefore get 3 times x. 3 times 1 is 3. The rest of the equation remains the same. So we now have 3 plus 2y equals 7. Let's move things around. That would mean 2y equals 7 minus 3. So 2y equals 4. Therefore, y equals 4 divided by 2. Y equals 2. We now have values for x and y, and those would be your answers to the question. It is worth saying at this stage that if you are not too familiar with rearranging formulas and solving equations in this method, it would be worth having a look at that before you go any further with simultaneous equations. I'm going to assume through this video that you are familiar with rearranging formulas, as we tend to do this throughout. Let's move on to another problem. Here we have a second set of simultaneous equations that we need to solve. Now, if I were going to add the two together, as I did in the last example, I would end up with 8x plus 6y equals 34. I have not eliminated either x or y, I have simply created a bigger equation. So we need to do something else. Now in this case, because we have the same value of y, they are both 3y, what we are going to do this time is we are going to subtract one equation from the other. And because one has lower values of x, I am going to subtract 1 from 2. 6x minus 2x is 4x. 3y minus 3y is again nothing. So by subtracting, we have now eliminated the y, and this time we have to go 21 minus 13 is 8. So we are now left with 4x equals 8, and rearranging in the same way as we did before, x equals 8 over 4, therefore x equals 2. So again, we have found x first. We're going to do exactly the same now as we did before, so we are going to substitute x into, and again I'm going to use 1. I could use either of them. So this time x is worth 2, so putting that into the very top equation, that means 2 times 2, so we have 4 plus 3y equals 13. Let's move things around. 3y equals 13 minus 4, therefore 3y equals 9, so y equals 9 over 3, y equals 3. And that is the second part of our answer. So the method is pretty much identical to the first example, except we had to change the initial step that we took in order to eliminate the y. Okay, here's our third set of simultaneous equations. Now, let's look at the first two methods that we use. If we add them together, we would get 5x minus y. We haven't eliminated anything. Also, if we take one away from the other, the numbers are such that neither the x nor the y would go to 0 no matter which way we subtracted. We therefore need to add an extra step into this particular set of equations in order to move forward. And looking at this, we have a 2y and we have a single y. A good thing would be to match them up so that we can eliminate them. And the way we do this is we actually multiply the second, number 2 here, by 2. So if we take the second equation and double everything, so we get 4x plus 2y equals 20. So each element of the equation has been multiplied by 2. This gives us another equation, which I'm now going to call 3. Now if we have a look at 3 and 1, we now have a minus 2y and a plus 2y. So now we can add 1 and 3 together. So we have 4x plus 3x, which is 7x. We have 2y minus 2y. Now we have eliminated the y's. 20 plus 8 equals 28. So we now find x equals 28 over 7. Therefore x equals 4. Again, first part of our answer. We now need to substitute the x equals 4, and again we could do it with any of these. Let's substitute x this time into equation 2. So x is 4, so we have 2 times 4 is 8, plus y equals 10, therefore y equals 10 minus 8, y equals 2. And there's the second part of the answer. X equals 4, y equals 2. And finally, our fourth method, and certainly the most complicated, let's have a look at the two equations here. If we add them together, we get 7x plus 10y. Nothing has been eliminated. If we subtract one from the other, again, there is no way of taking one equation from the other in order to remove the x or the y. If we were to multiply one of the equations, we cannot get the numbers to match in order to allow us to take one away from the other. Therefore, in this case, we have to do something that is sometimes known as cross-multiplying. So if we take the x's, and you could do this with either the x's or the y's, but I'm going to use the x's, and I'm going to multiply each of these equations by the opposite value of x. In other words, I'm going to multiply the top equation by 5 and the bottom equation by 2. Let's see why we might do this. So I'm going to multiply 1 by 5, and I'm going to multiply 2 by 2. Let's try this. Multiply 1 by 5. So we're multiplying the whole top row by 5. Therefore we get 10x plus 15y equals 55. I'm then going to multiply equation 2 by 2. So I get 10x plus 14y equals 50. Now, having done this, and of course we've now got two new equations, 3 and 4, we now have two equations where the value of x is the same. And that means we can take one of the equations away from the other. So I am going to subtract this time. Let's look at which has got the lowest value of y. It is 4. I am going to subtract 4 from 3. So 10x minus 10x, that means it's gone, 0. 15y minus 14y just gives us y, and on the other side 55 minus 50 is 5. Therefore this time we have solved y first, y equals 5. Now that we know that, we are back to what we did for the first 3 examples of putting y into any of the equations. So I am going to substitute y, and this time I will put it into 1. Equation 1 here starts with 2x plus 3 times y. Well, I know y is 5, so 3 times 5 is 15 equals 11. Let's move things around as we did before. 2x equals 11 minus 15, therefore 2x equals minus 4. X equals minus 4 divided by 2, x equals minus 2. Again, we've now got our solution. So we have 4 methods, and the problem is it is not possible in a video such as this to tell you which method you need to use for any given problem. You need to simply look at the figures and make that decision. So method 1 is adding the equations together. This one you would use if you have a plus and a minus value of either x or y which is the same, so that by adding them together you are eliminating the x or the y. Method 2, subtracting one from the other. This is particularly useful if you have the same value of x or y in the two equations, because by taking one from the other it then eliminates it. Value 3, multiply one equation. That is where you'd have a value of x or y which is a factor of the other equation, so that by multiplying it up you equalize the value and therefore you can then subtract them. Cross multiply is when you cannot really see any correlation between any of the x's and y's, and you simply need to find a common multiple of x or y to make them the same, so that you can then go ahead and subtract them in the next stage. It is quite common in an exam for a question to simply ask you to solve a set of simultaneous equations. However, there are situations where the question is slightly more hidden behind an explanation, and here is such an example. It says the cost of 3 adult tickets and 2 child tickets is £73. The cost of 2 adults and 5 child tickets is £89, and it's asking us to find the price of an adult and a child ticket. So the first trick is to recognise that this is a simultaneous equation. So let's say that an adult ticket is A and a child ticket C. We can then change the two statements here into equations. So we have 3 adult tickets, 3A, plus 2 child tickets, 2C, and we know they add up to £73. We also know that 2 adult tickets, so we have 2A plus 5 child tickets, 5C, equals 89. Now we have a set of equations, let's call them 1 and 2. We have to decide how we're going to go about solving this question. Can we add them together to eliminate? 3 2 is 5, 2 plus 5 is 7. No, we can't. Can we take 1 away? No, because if we take them away, we still end up with A's and C's in the equation. Can we multiply one of them so that the numbers match the other? Well, 2 doesn't multiply up into 5, 2 doesn't multiply into 3, so we can't do either of those. Therefore, in this case, we are going to have to cross multiply. We are going to multiply equation 1 by 2, and we're going to multiply equation 2 by 3. So these are the two numbers on the beginning here. Let's do that. So multiplying 1 by 2, we're going to get 6a plus 4c equals 146. Multiplying equation 2 by 3, we're going to get 6a plus 15c equals 267. Let's call these 3 and 4. Now we have two equations where the value of a is the same, so we can subtract one from the other. So the next thing we're going to do is we are going to subtract. Let's have a look at the values of c. 3 has the lower value, so I'm going to subtract 3 from 4. 6a minus 6a, that means a has been eliminated. We have 15c minus 4c, which gives us 11c. We have 267 minus 146, which gives us 121. So 11c equals 121. That means c equals 121 divided by 11. So c is in fact 11. Let's substitute that into one of the equations. So we're now going to substitute c into, and we can choose again any of these. Let's use 1. So that means that we have 3a plus 2c, c is 11, so 2 times 11 is 22, equals 73. Therefore 3a equals 73 minus 22. 3a therefore equals 51. A equals 51 divided by 3. A equals 17. So c equals 11, a equals 17. Going back to your question, that means a child's ticket is £11 and an adult ticket is £17. So I hope you found that useful. I really do think that the best way now to move forward is to get yourself some problems, try them out and see if you can identify the best route for each of them and get used to looking at the equations to decide the best way forward. If you have found that useful, please do hit the subscribe button below here and you'll find another video to my side which you might find useful. Hopefully I'll see you again. Thank you.